Hello viewers, a very warm welcome back to the class. In this video, starting discussing the detailed video solution questions that came from subject power systems in electrical engineering. So basically 6 questions from power. 3 of 1 mark and 3 of 2 marks, total 9 marks of basically moderate level. I would say. In this video, we'll start with the first question, question number 24 about the master question paper of electrical engineering from subject power systems. This is a 1 mark MCQ type. The question goes like, during a power failure, a domestic household uninterruptible power supply UPS supplies AC power to a limited number of lights and fans in various rooms. As per a different absent load flow formulation, the UPS will be represented as a given as A slack bus, B PV bus, C PQ bus, and D PQV bus. This is actually a theoretical question based on some fundamental understanding of the classification of buses in load flow analysis. There is nothing to write, like this is a theoretical question basically based on conceptual understanding. So let's discuss the solution. During a power failure, the domestic household UPS, the uninterrupted power supply, supplying AC power to a limited number of lights and fans in various rooms. It asked, the UPS would be represented as the UPS represented what kind of bus, right? That is basically the question. So the kind of buses in that we deal in load flow studies, there are 3 types. Right? Oh, we all know, still I'm writing. Flat PV, generator, right? One loads. Slack bus, what is the specialty? The voltage and the phase angle remains constant. Basically, the slack bus is one which is infinite active and reactive power control comes. It is the reference bus for the phase angle and yeah, because the phase angle is taken as 0 general, 1 angle 0. I mean, and phase angle is 0 degree taken as the reference, and yeah, and the magnitude is taken as the rated value, the per unit value. That is the 1 per unit, 1 angle 0 for the slack bus. We was here constant, the power delivered, outgoing power, and the voltage. It was a constant. For PQ, the power and the maximum reactive power. P and Q are held constant, maintained as constant or assumed to be constant. P was for the maintain voltage constant, it must have infinite or sufficiently large reactive power. Does it have? Then it is unable to maintain the voltage constant. It gets converted in subsequent iteration. Right. But in this case, as the question says, the domestic household power supply UPS uninterrupted power supply supplies the AC power to limited number of fans and lights and fans. But for the domestic household power uninterrupted power supply, the loads here are basically lights and fans, right? And UPS basically supplies power to all those equipments or say household appliances, right? So basically, it must have sufficient capacity to deliver all those lights and fans that are used in the house. Two power options are there. It cannot be a PU bus, not going forward, it not lower. It is generating power supplying forward to light and fan. What's the idea of that or PV? There can be confusion among these two only. Either black or PV. Either of them. So which one to choose? See here. It can be considered as PV also, but since it has infinite, sufficiently large power capacity, supplying AC power, that means the light electrical meter will not be active power. But fans for the starting power, single induction motor, they draw reactive power as well. So who is supplying the reactive power here? UPS supplying AC power, active plus reactive. So it must have sufficient capacity to deliver all the lights and fans. Right. Only at certain active power, like it deliver generator is not enough for the UPS. One power of the reactive power. So sufficient active and reactive power black power. Right. In any conditions, it can be anything with loading can be anything. Total capacity the is much. Specific power output is okay, but this should be able to cater the maximum loading. So this is the sufficient active and active power which corresponds to the conditions that are applicable for basically slack bus. Slack bus की जो condition होता है वही यहाँ पे यूपीएस फुलफिल कर रहा है. Sufficient active and reactive power तो लाइट्स एंड फैन सप्लाई तभी तो ऑपरेट कर देंगे ऐसे सिलेक्शन. और यहाँ पे और तो बस रेफरेंस भी नहीं दिया गया तो वी कैन टेक द यूपीएस एज अ स्लैक बस. So basically, I remove the condition PQ bus cannot be for the reasons already explained. So basically, the correct answer is the gate authority is also given, and I also think initially I also thought that but as there is no reference bus which is active, insufficient that active and active power, the right in that may be considered for international formulation as a slack bus. So the correct answer to this question is option A. We try to explain the different types of buses, classification of buses that we use in workflow studies, the characteristics of each bus, and how the applicability of the classification to this case, conditions given, scenario given, and from that I try to infer that the UPS using the domestic household can be considered, should be represented as a slack bus. Whose solution is clear and consider? That's our solution. Thank you. Hello viewers. Moving on to the next question in the series of gate electrical solutions from subject. In this video, we will detailed solution of question number 32. Subject or is 1 mark, anything or no answer take. And the question is given as consider distribution feeder with R by X ratio 5. At the receiving end, a 350 kVA load is connected. The maximum voltage drop will occur from sending end to the receiving end when the power factor of the load will dash. Round off to 3 decimal places. Right? This one is solution question. Let's draw a distribution feeder. One. Phases given with the right going the feeder with I from the single ratio. Yes. Clear? Must be very clear. Now, with respect to the receiving end, let the receiving end be at the current lagging at a quarter triangle of 5. Okay. The voltage drop is given by No, take a I into Z. I into Z is what? R plus J. R plus J you take X of I R is J1 basically. Right? So I times R is the expense delta I cos by 1 J times 5 plus 0. So I cos by I cos by plus and the number cos by minus. No, for long like yeah. And the order name is very small. Right? Small. This support is much greater than appreciably greater than this. This one will be appreciably greater than this. So this is nearly equal to negative. Nearly equal to I I for the approximation is really but it holds. So the part of angle is very small. Negligible is opposite to this. So let's plug in. Let's differentiate with respect to phi. I make the part. What is the part of the angle? That is the load. Right? Load is not the current, so we can change its part of the angle. Okay. Phi. Delta V is the maximum delta V, that is the voltage drop. We have to fix the derivative. Take the derivative. For phi derivative is minus sin phi. And sin derivative is cos phi. So we get what? Sin phi. Then we will start using equal to sin phi cos. Sin phi equals sin phi about cos phi. What? 1 by phi. Correct? Tan phi 1 by phi. Perpendicular to the hypotenuse is 1 by base is 1 by pi. Yes. What? Hypotenuse to be 2 hypotenuse from this inside for base by hypotenuse. I prove vertices. So maximum what is the nearly equal to what should I measure? It is 0.98. That is more than So basically, example to three decimal places, 0, 1, and round up three decimal places. So that's the answer to this question. I try to solve it using a very basic computer, taking the voltage and voltage, easy one voltage, taking the receiving voltage the reference, considering the load is current here, going this current, lagging power factor of 5. So I look at the basically voltage now, the function of I and Z, maybe the linear function of I and 5. The parameter constant, I is constant, look, take constant, take it to the line, high, low power factor, and change. That in the low power, the thing that is about big term, the voltage low. Now, this term for distribution feeder, small length, puts a power factor. So, within negative, so negative, approximate value, distribution component you power factor active power voltage low, differentiate the power angle and you open the first angle, then the rating for the power factor what 9 to 30 basis for maximum voltage drop. That is not 10 meters. I have explained in very detailed, good explanation. Hope the solution is clear and comprehensive. Student Dr. Fight, please ask my comments. And that's all about this question. Thank you. Hello viewers, moving to the next question. This is a great video that actually in solution to the problem. In this video, we will details with question number 33. About the master question to the subject or systems. So one mark, email answer type anything. Question was like, bus impedance matrix for given power system in per unit is Z was equal to J 0.05 and J 0.04, J 0.03, J 0.02, J 0.02, J 0.10. A symmetrical fault to fault of J 0 per unit occurs and was negatively for loading condition. The voltage was not during the fault round up to 6 decimal. Let's move to solution to this question. Let's move to question fault analysis in zebra matrix. Now we go for schematic. Like, let's assume it's not given, so let's assume that negative preferred voltage. So the normal voltage is preferred voltage at the nominal values of 1 current. We have taken that. Just the voltage at bus 1 during the fault. The symmetrical fault of fault impedance of ZF equal to 0.002 अगर at bus 2. Basically, what happens is this part is going to the impedance that was existing earlier, but now Now let all the series. So you will from here, voltage. Yes, so voltage by first connected to what the path of water. Correct. Voltage drop is for the first one filter absolutely minus because evaluation. Right. For everyone, right? I is what? Z22 plus Z. Now there is the magnitude. So, this is one. That's recall information. I will one by this then what is the so like the one is very correct. So from here we get one minus 2.1 delta V1 V1 is 1 so V1 prime the fault condition is V1 the fault conditions symmetrical fault conditions the voltage at plus 1 will be V1 plus change into V1 1 minus 1.9 perfect to the voltage waveform serial is not coming to this conclusion serial bits can be zero can be good it is not required okay as a point yeah so I hope the solution is clear explain the concept in detail to obtain the answer as 0.29 not 390 right to 1 right pretty clear solution we will question of this the coordination and the voltage impedance and what is this concept what the current that for mutual impedance for the voltage and the other was to change you want to calculate the voltage drop adding the voltage of the before voltage at the first one obtain the voltage at verse one new voltage if any middle of this clear and comprehensive student also guys please ask me comments that's all for this question thank you Hello viewers, moving over to the next question in this series of gate-related solutions not subject. In this video, I will cover detailed video solution question of 49. So you have 2 marks which is type the master question from gate-related subject or systems. It is based on accelerating displacement here of power angle curves during fault. And the question was like in the system shown below, the instant generator was initially supplying power to the temporary triple MC fault. The symmetrical fault fault occurs at F close to centimeter 1. Here. The circuit breakers open to isolate the fault, isolate the line. The fault self clears. Circuit breakers reclose and restore the line. Which one of the following diagrams best indicates the local experiment? Right. For figure power angle. Power versus rotor angle. Let's move to solution to this question. Very simple, basic, based on fault analysis, stability analysis. In the diagram of power system given, very well, they are track two transformations. On one hand, there is certificates and for other means one. The other time there. So, in the preferred condition, as both the powers like the power of the reactance of the input and the less. You know, power is here. I get the distance as 2 meters. One is in parallel 2 days. So power greater. 2 meters delivering power. Right? So in the first case, each of the people with the time delivering power, 1 meter maximum power higher. This is the upper side of the pre-fault. During the fault, the line will go, bottom line will go to the power, maximum power of the degree. So curve is downward. Okay. But the power delivered is not zero. Second case, mind. Right? Power delivered is not zero. The lower one to the positive. The power delivering capacity increases. In the preferred condition, there was some good amount of power there. The positive condition, the power increases, but it does not reduce to zero. Electric power is zero. So when the power load angle cannot change instantaneously. So the for that same rotor angle, the maximum power decreases. So instantaneous power decreases. Like this. Curve comes down. But the mechanical power input to the generator doesn't change instantaneously. It remains at it is preferred. So as the accelerating power, so PM is constant, but P is right. So what happens? Preferred pure pull. Now P reduces, PM reduces power. So the rotor accelerates. So accelerating is the area between the preferred power and the power under the fault condition, electrical power. And the preferred power getting the response. So this may be the part of where you work, the what, okay. Now, avoiding the instance or or incident for creating the output, we have to be confident. Even for it, even confident. So, there is actually E positive, E positive. Okay. Then what happens? One of the sentences open to applicable. Opens. What is here? It was a mistake of it. So mainly the power again it comes back to its original maximum capacity after the user. Okay. Okay. During the part it was fixed. Okay. Right. Suppose at this point the diagram. So motor keep on accelerating. P given P. So the motor starts accelerating. Again. But in next year, continuous accelerating. Rotating usually in of course at what? Okay. Let's say at this point what happens? The whole clears. So it gives me value for the power. And again, give me its within the inertia. I will see. So the the higher than the end period for backward, but inertia will not be forward. Total angle keep bringing up a certain point. So this is a positive for so if you can do that, what? It may be a scheme of given why the point continue further will be accelerated. And here P is greater than P, the progress. Right? Obviously, here, how the mechanism is going on, how is the rotor swings, how the rotor swings going on, dynamically. So the theory is the principle corresponding to this linear rotor corresponding to this the options that B for the figure 2 matrix to be 12. Figure 1 doesn't match, right? Figure 1 doesn't match because the initial power transfer. This is the matrix negative wall. The power is inverted. You just stated it. So it is referred to that. So this is the story in United States. And for the positive expansion, it's not correct because we are able to zero instability. He is thinking and he considered zero. And the difference is stability. So this is not correct. It is 4 or 6. You consider he is zero. So correct graph, correct diagrams that indicate the rotor acceleration instantly is either to that is option B. I have drawn the risk for another for negative positive power that is equal to the material point of conditions, people conditions, and the power material point of output the point actually one is the zero power solution. There is gives one line below with one line below particular to material power output the curve. So the first accelerate will be quite. Then again it gets a bit further due to inertia, and then the maximum get. So this is the target stability phenomenon that is synchronous generators. Yeah. So the question is option B. Then digital mechanism approach. Mobility claim comprehensive and also correct. That's what the solution question. Hello viewers. Moving on to the next question. It's a great question number 63. Master question of power correction using shunt capacitors. Question is posed using shunt capacitors, the power factor is 4 kV. Induction motor drawing 90 kVA at 0.77 pf lag is to be connected to 0.85 power factor lag. The line current of the capacitor 19 ampere is down to 1. The solution is pretty simple. Calculate based on power factor correction. Initially, the induction motor was 90 kVA constant power. So, power motor 90. Due to the calculations at end, आपको calculate करेंगे. And JMP power 90 KVA means first I compared to the active power, then I compared to the reactive power. So for first I compared 1 minute ऐसे क्या नाम है? So basically this was the job active reactive power drawn by the induction motor. Now to increase correct the power to 0.85 power from the power. The power factor EM power is equal to the reactive power EM times factor that is EME point 10. The manual corrected power is 0.8. 10 of phosphate point 10 of desired reactive power of the motor. Difference in power. And because the water is better, the water is less. The that water is absorbed, and that is given. Usually, the water is absorbed, right? So, compensation is water. Previous, you see, doesn't matter. It. The compensation for you are one right. Usually, subject with a capital. Second better. Then take the values from the question. That will come to different again with your treatment time. Take main for rating for the supply. Now, this is power. What? DN, IS, for right? As the capacity the voltage current 90 degree out of phase, so it will make it root to be like 90 ये government is specified that when we area, so three times more to IL. So in empty input, so 1.7 plus that one. From this expression, you can put IL. Do this also in what remove this, taking this here, you put in the not to calculate again and again and now and do the approximation. If we calculate directly at the last, it will save time and also improve accuracy. So that will currently I am observing there is the range of 810. So that happens that is how one. One. So I hope the solutions clear properly. That was the question. Thank you. Hello, viewers. Moving to the next question, last one. This is a question 64. This question will be with this video. These are 2 marks. New answer type from the question was like the 2 units rated at 100 megawatt and 150 megawatt are enabled for economic dispatch on the overall incremental cost is 10,000 rupees per megawatt hour. The units are dispatched 50 megawatt and 80 megawatt respectively. The overall incremental cost of 10,600 rupees per megawatt hour. The power output units are 80 megawatt and 92 megawatt respectively. Total plant out megawatt output without overloading a unit at an overall incremental cost of 11,800 per megawatt hour is round up to nearest unit. Let's move to the question. So we have to solve two simultaneous questions. Yeah, let's move on. The incremental cost for the dispatch should be equal for the those entities. 20 by V1 linear function of P1 or P1 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 equal to the equal focus to under the uniform speech condition this two equals now two values of overall given the first and given. One is 10,000. 10,000 same in case of 10,000 equal to 15 for unit 1. V1 plus V1 is 1. And for the unit 2 also, we have 80 plus another condition 10,600. So the output of the units are 50, V1 is 80, 50, V1, 94, 82, 52, taking megawatt. Four unknown subjects, four individuals. This called number one. Subject minus 200 equal to minus 32 equal to minus 58. Regular E1 is 30, 30, 30 equal unit equation first. You move them back to get what? E1 is 10,000 minus 50 that is minus that way 10,000 minus 58. Calculate solving data for one. A1 is 20, A2 is 50, B1 is 9,000, and B2 is 40. The zero fixed so that there is no concept. Find the forwards. So the both values are A1 and A2 and B1 20 B1 plus 9,000. Here, we are looking at 80 into plus. We move the information to 1,800. We are going to value B1 and B2. So B1 we can get the equation. It is visible. How we get it? We will now minus 9,000 divided by 4,800 minus 6,000. So 5,000. And it's just coming 140 and but you can see that so we need one the limit for 100. For it is going to make for 150 greater than 100. No question. Greater than 1, read for 150 will move the read for 100. So You will question that no. So to restrict P1, the power of implement control is very relevant. And the P can be tested significantly 160 So maximum total plant area output is plant P1 is equal to 100 into 216. 216. Yes, this is already increased. And this is already discussed this is just mathematical solution only, or not nothing to grasp the concept and all. Hope the solution is clear. Please have a look at it, go through it, all the statements, approach, take a check. Usually and also queries. Welcome, ask my comments. And I hope I will be able to clear your doubts and yeah. So that's all for this question. The new question also subject power systems. I discussed all the questions. Hope you understood. If you still have doubts or queries, please feel free to ask in the comments. The respective videos or on the comment. So that's all for this question. Also subject power. Thank you.